And so, quick review here. Yesterday we started talking about the trig functions or the trig ratios, and we gave a couple different ways to approach these. Most everybody's familiar with the opposite adjacent and hypotenuse approach. Gave some mnemonic devices so you can remember how those work. However you remember them, I don't care. Just make sure you've got them memorized. If you know this really well, you've also got to know how to write these down in terms of x's, y's, and r's. Okay? So we don't just think of sine as opposite over hypotenuse. You've got to think of it in terms of y's over r's also. Okay? We talked about the reciprocal trig functions. We gave 5 identities, true equations that you need to have memorized for the next test. If you have those memorized, you got 5 points automatically on the test. Okay, so make sure you've got those memorized. We went through and we found the 6 trig functions for this particular point on the xy plane. So we figured out what the x coordinate was, what the y coordinate was, what the radius was, and then completed those. We also went through and we figured out what the sine, cosine, and tangent was for each one of the quadrantal angles. Okay, so we drew some exaggerated triangles in some cases. And then we talked about the special right triangles. Hopefully this was something that you were familiar with. 45, 45, 90 and 30, 60, 90. On a 45, 45, 90, please make sure you use 1 for the hypotenuse or for the radius. That means both legs are radical 2 over 2. That would be better than a different way if you happen to memorize a different way. And on a 30, 60, 90, the small leg is always across from the small angle. So this is the big one. That's a 60-degree angle. Everything on a 30, 60, 90 goes through the small leg. So if the hypotenuse is 1, the short leg has to be 1/2, and the long leg is going to be radical 3 over 2. We then used those ideas to figure out what the sine, cosine, and tangent was for 30 degrees. Notice that 30-degree angle, okay, and that 1/2 over here. Sine, cosine, and tangent for 45 degrees. Sine, cosine, and tangent for 60 degrees. Okay? And then I left you with this question right here. It says, do you notice anything about the sine and cosine for each angle in comparison with the x and the y coordinates of the point on the unit circle? So we're talking about this point and these 2 trig function values. This point and these 2 trig function values. This point and these 2 trig function values. Please tell me somebody spent at least a little bit of time thinking about how those are related. Yes, Diana.
Cosine is the x-coordinate and the sine is the y-coordinate.
We are going to write that down exactly because that is profound. That's exactly what it is. Okay, the cosine of the angle is the x-coordinate of the point on the unit circle, and the sine of the angle is the y-coordinate. Okay? It's that simple. Now, let's just double check and make sure. X coordinate needs to be the cosine. So the x coordinate here is radical 3 over 2. Radical 3 over 2 there. Y coordinate is 1/2. Sine is 1/2. Okay? They're both the same on this one, so that's not a good one to check. But here's the cosine. That's 1/2. And here's the sine. That's radical 3 over 2. So as you look at those, if you know the points on the unit circle, you're going to know the sine and the cosine for each one of those angles. Okay? So what I want you to do is flip over to this guy right here. Take that back, that guy right there. Okay? Now, for this first little bit, here's what I'd like you to do. I'm going to start writing these down. Okay? I want you to look up here. Okay? Don't be looking at your paper. And I'm going to give you a tiny head start. You should be able to do it this quickly because you're going to need to be able to fill this out or at least recall these things instantly. So I'm going to run around here and write down the angles in degrees. Don't look at your paper. You just look at the slot I'm going to fill in next. If you can say it before I write it, you're probably in pretty good shape. So this is 0 degrees.
30.
Oh, we're going to say it out loud. Very nice. Okay? So this one's going to be, tell you what, I'll just give you a head start. I'll say it, you think it. As long as you can think it before I write it, then we're in good shape. So this is 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, slide down here, whoops, 270, 300, 315, 330, and all the way around is 360. Now, if you were right on or a little ahead, that's okay. If you're behind and couldn't come up with it that quickly, those are degrees, for crying out loud. Those have to be absolutely second nature and very, very fast. All right? If we do this in radians, let's run through and do this. I'm going to write down the 0. I'm going to give you a little bit of a head start. And you need to think it before I write it. So this is going to be pi 6, pi fourths, pi thirds, pi halves, 2 pi thirds, 3 pi fourths, 5 pi sixths, pi. Coming down here, 7 pi sixths, 5 pi fourths, 4 pi thirds, 3 pi halves, 5 pi thirds, 7 pi fourths, 11 pi sixths, and all the way around is 2 pi. Now that probably was a little bit more difficult. If you can't stay up with that, that was actually a little on the slow side. You should be able to come up with them as quickly as you can write. You should know exactly where they are, okay? And if not, you're going to find today that, gosh, I took pre-calculus, or I saw this stuff in my Algebra 2 class. I don't know how to do this problem. I can't do it as quick as everybody else, okay? It takes practice, okay? But it's worth it. Okay? I reminded you yesterday. In Chapter 1, if you know Chapter 1 really well, if you know this stuff absolutely rock solid, the rest of the course, not bad. If you don't know it, you are crippling yourself. Okay? So we have a long weekend coming up. I would make sure you have all of this straight when you come back next Wednesday. Okay? All right. So let's run through here. And if we know this, okay, so this is what this is for down on the bottom, cosine of alpha is the x-coordinate, and the sine of alpha is the y-coordinate. Well, let's go ahead and let's fill this in. Now, I can't have both of these on the screen at the same time, but if you want to have this page right here so that you can see that, and you might need to quickly flip over here to example 2 on the other side so that we can fill this in. If not, then we're in pretty good shape. So I'm going to leave that right there. Let's run through here and take a look at this. Now, let's start right here. The x-coordinate is the cosine. Well, if this is the unit circle, I went out 1. I went to the right 1 and I didn't go up or down. So this is 1, 0. And if you check example 2 on the first page of your notes, that matches up with what we had. This is the cosine of 0 degrees, and this is the sine of 0 degrees, or radians, if you will. Okay? All right, so let's take a look at the next one, and everybody watch, please. Here's the triangle on the next one. I'm going to go out to 30 degrees, drop a line straight down to the x-axis, remember. That means this is the short side of a 30, 60, 90. So this one's 1/2, and this would be radical 3 over 2. So that means I've got radical 3 over 2 and 1/2. That matches with what we had on that example on the notes. This is a 45, 45, 90, so I go out, drop a line straight down here. That means both of these are going to be radical 2 over 2, radical 2 over 2. We doing okay so far? Next one, for the 60-degree angle. Go up to 60, drop a line straight down. That means this is the short leg on a 30, 60, 90. So that means the x-coordinate is 1/2 and the y-coordinate is radical 3 over 2. We doing all right? Okay, don't go right or left. We're just going to go straight up 1. So that's 0, 1. Okay, if you don't know this quadrant right here and don't have that memorized, then you're going to be in big trouble. Okay? Because then you can't figure out the other ones. So if I take this point, and I don't care how you get these memorized or how you keep it straight in your head, there's lots of symmetry, there are lots of little tricks to figuring this out, but here's one, just use the symmetry. If I take this point and slide it right over there, it's the same distance above the horizontal axis, it's the same distance going up, we just changed the x-coordinate for going to the right to going to the left. So this one is negative 1/2 radical 3 over 2. Negative radical 2 over 2, radical 2 over 2. This time we went back radical 3 over 2, so that's negative radical 3 over 2, comma 1/2. It's just like this one over here at 30 degrees. Just slide that straight over. It corresponds to that one. It's just got a negative x coordinate rather than a y. And we trade that positive one for a negative one, so we've got the top half of the unit circle right there. Okay, are there any questions? All has to be absolutely rock solid, all memorized. Okay, so if I go over to here and I go down, that's going to be negative radical 3 over 2, comma negative 1/2. Negative radical 2 over 2, negative radical 2 over 2. Notice that we're in the third quadrant, so both coordinates are negative. And this one's going to be negative 1/2, comma negative radical 3 over 2. And what if we don't go left or right, we just go straight down one? What are my coordinates here? 0 and negative 1. Okay, stop right there. How are we doing so far? Okay, I want your eyes up here. What if I said, what is the cosine of 270 degrees? It's 0. Because it's got to be the x-coordinate at 270 degrees. And if I said, please tell me the sine of 210 degrees. Sine of 210 degrees. We go find 210. Sine would be the y-coordinate, negative 1/2. Okay? It's literally that simple if you have the unit circle memorized. So this one right here, this is going to be 1/2 negative radical 3 over 2. This is going to be, radical 2 over 2. Negative radical 2 over 2. This is going to be radical 3 over 2, negative 1/2. And again, if we go all the way around the circle, we're back to the same point. Now, I had you might just want to be aware, this doesn't only mean, because I'm saying, hey, this is the unit circle, can I make this smaller so you can see the whole thing at once? Good there? This doesn't only mean that we're limited between 0 and 360 degrees or from 0 to 2 pi. That's not what this means. This means these are the ones that you're going to have memorized. But if I say, hey, could you tell me what the cosine is of negative 30 degrees? Negative 30 degrees would be right here, radical 3 over 2. Okay? If I said 4 pi and I need the sine of 4 pi, 4 pi would be 2 pi, 4 pi, 0. Okay? We're not just stuck to 0 to 360. Okay? Okay, we can go with coterminal angles. That's why we learned that in 1.2. Okay, are there any questions there? Yeah.
So on the test, will we be at least given a blank unit circle so we can fill it out and then do it, or do we have to just have it in our minds pictured?
Would I give you a blank sheet like this?
Would you?
Sure. Okay. Now, okay. If I tested you on the whole thing, I probably would. If you were going to do this on your own, then you'd probably want to do something like this. Okay. At least get the first quadrant right. Okay. So draw it like this. Okay. Draw the middle one. And then they're not equally spaced, remember. These guys are a little bit closer to each other. So you can get started doing that. Okay. But if it were a test, yeah, I'd give you a blank one. Okay. I don't want to have you, waste time in math doing art. Okay. We good? Okay, good question. Okay, let's come back here. Okay, if you have that memorized, then you're in really good shape. Okay, that really sets the stage for the rest of the course, and these are basic facts that we're going to recall over and over and over again. Okay, but it's really important that you understand how trig functions work, why we use them. Okay, they tell us, given an angle, what the ratio of the sides is. Okay, so they will just tell us what that ratio is. So I like to keep it straight this way, and if you'll remember this phrase this way when we do some stuff later on in the chapter, you're just going to be in better shape. So please don't forget that trig functions take angles and give ratios. So if you've got a trig function, you give it an angle, and it will tell you what the ratio of the sides is. So if it's a cosine function and you give it the angle 45, it's going to say, well, the ratio of the adjacent over the hypotenuse, or the x-coordinate over the r, over the radius, is going to be radical 2 over 2. Okay, that's what they do. Okay, fundamentally, that's what's going on. So when we do problems like this, all we have to remember is This is the sine function. We give it an angle. We're looking for a ratio. So the answer that we're going to put right here is a ratio. Okay? So I'm going to blow this up just a little bit so we can work. And yesterday in class, Mai said, hey, can you zoom in so I can see? If your eyes are bad or I love the tablet, but if I slide the page past something so you can't see what you need, okay, or it's too big or too small, just let me know and I'll adjust it so you can see what you need. Okay, everybody good there? So if I were doing this problem, okay, I can do these without doing a whole bunch of work because I've got them memorized so well. But if I were doing this problem and wanted to keep straight, here's exactly how this works and why it works. This is how I do this problem. I'd think, okay, the angle is 45 degrees. So I'm going to draw it right there. It's in the first quadrant. That means this is 1, this is radical 2 over 2, and this is radical 2 over 2. And I need what ratio? The sine ratio. So I need the opposite over the hypotenuse. The y-coordinate over the radius. So this is going to be radical 2 over 2. Notice that this right here is an angle, and this right here is a ratio. That's fundamentally what they do. Now, if I have the unit circle memorized and I can just think, hey, you know what? At 45 degrees, both the x and the y coordinate are radical 2 over 2. I need the y coordinate in this particular case, but there's the answer. Either way there is fine, but this is why it works the way it does. So let's take a look at the next one. This is the cosine of 7 pi 6. So I'm going to do the same thing. I'm going to think or draw 7 pi 6. That's why you've got to know where these are. This is 1. This is the short side, so this is 1/2, and this is the long leg. This is radical 3 over 2. So take a good look at that. Yesterday I said I guarantee some people are going to mess this up on the test and they're going to lose points because they make a silly mistake like this. Please don't let it be you that loses points. The odds of seeing something like this on the final are pretty good because they know people typically make mistakes like this. What I've drawn here is wrong. How is it wrong? They should both be negative, right? Because I literally went back, I went to the left, and then I went down. The x-coordinate should be negative, so should the y-coordinate. Remember, the radius of the hypotenuse is always positive, but the x and the y-coordinates, they can be positive or negative. So if I want the cosine of 7 pi 6, which coordinate do I want? I want the x. Okay? I want the one that runs along parallel to the x-axis. So this is going to be negative radical 3 over 2, and there we go. Okay, any questions? Let's look at the next one, sine of 150. Now, I don't really have to fill the entire thing in. If I know I just need the y-coordinate, if I know I just need this guy right here, if you want to think a 1 here and a negative radical 3 over 2 here, and please think that, it does have to be negative, this would be positive 1/2 because we went up half a unit, so this is positive 1/2. Any questions? Okay, let's take a look at cosine 2 pi thirds. Again, you've got to know where they are. 2 pi thirds is here. You've got to know that this angle right here would be 60 degrees, so that means this is the short leg, so this is negative 1/2, and it has to be negative. This would be radical 3 over 2. We really don't care about this. We only care about this one right here. It's negative 1/2. Oops. Good? Okay, here's one of those I said we'd come across. This is not an angle that's on the unit circle that we typically fill in, but we can find one that's coterminal with that. Negative pi fourths, 45, 45, 90. In the fourth quadrant, again, we always form this little triangle with the x-axis. Which one do we want, the x or the y? The adjacent or the opposite? We want the y. We want the opposite one here. I'm going to write radical 2 over 2 because that's what they are if the radius is 1. And what mistake have I made? Got to be negative. So the answer is negative radical 2 over 2. Okay, are there any questions there? Okay. Tangent of 45. These are both the same, right? Radical 2 over 2, radical 2 over 2, so the answer here is 1. You got to at least think that. Okay, look at this next one. Tangent of pi halves. Tangent of pi halves. Well, how would I draw a triangle for that? One of those exaggerated ones. So I'm going to slide it over just a little bit. Draw a triangle with the x-axis or the y-axis? Always the x. So this is 1, this is 0, and that's 1. Opposite over adjacent, y over x. Either way, it's 1 divided by 0, so this is undefined. Tangent of 60, here's 60 degrees. Radical 3 over 2 and 1/2. Same thing, it's going to be the opposite over the adjacent, the y over the x. So if I do that, here's what I get. I get radical 3 over 2 over 1/2. And I never divide by a fraction. I flip the bottom one over and I multiply, so that would be timesing by 2. Those are going to cancel, so my answer on this one is radical 3. And I think that's confirmed if you look at example 2 in the notes. Okay, I think that's what we found for 60 degrees. No, it wouldn't be example 2. It would be the example on the next page. I think it was 3. Okay. Any questions? Negative 135. We're thinking this. 45, 45. What do you know about the two of these? Okay, they are negative and they're the same number. They're both negative radical 2 over 2. What happens if you take negative radical 2 over 2 and put it over negative radical 2 over 2? You get positive 1. So it's a little odd that we end up with something where the quadrant, we've got negative coordinates and we still end up with a positive trig value. And would you go ahead and write down the cosine of 315? Hopefully at this point you can just think about it and visualize 315. That's going to be here. I'm looking for the x coordinate. It's a 45, 45, 90, so it is radical 2 over 2. Positive or negative? Negative. Positive because you had to go to the right to be in this quadrant right here. So that's going to be positive, this guy right here. There's our answer. Okay, any questions? Sure? Okay, if you'd flip back to the unit circle, I just want to point something out. I'm going to give you a nice looking one of these, probably tomorrow, or I'll show you where you can download it. You do need to have this memorized, but there's something else that you ought to be aware of. It might be good to know the tangent ratio in the first quadrant, and it's also good to know this. You'll notice all of the coordinates are positive, so that means all the trig functions would have to be positive there. Okay? In this quadrant over here, the y-coordinate is positive. Anything that involved an x-coordinate would have to be negative, and all the other ones involve negatives. So I'm going to write it this way. This is a little way you can remember which ones are positive. We're going to write all students take calculus. So they're all positive here. This starts with an S, so sine or anything related with it would be positive. This starts with T, so tangent or anything related to tangent would be positive there. And this starts with C, so cosine or anything related to cosine would be positive there. That's not a big deal. It will be later on. Just kind of keep that in the back of your mind for now. Okay? Any questions? Okay, let's go back here and finish this up. You might need a calculator for the next couple because I certainly can't do these problems in my head. So here's the first one. Sine of 43 degrees. Again, we're going to give it an angle, and the calculator is going to give us a ratio. So let's make sure that we're in degree mode. If you've got a scientific calculator, it should say DEG at the top to tell you what the mode is. So I'm going to put this in degree mode, hit enter, clear this off, and I'm just going to type in the sine of 43 degrees. Literally, we just type it in like that, and the answer is 0.682. Okay, is everybody watching? Okay, I need you to think about this for just a second because it's fundamentally understanding how these work that's going to be really helpful in the long run. Starting in Chapter 2, we're going to use these ideas to do lots of cool stuff with trig functions. Here's the idea that I'm after here. If we start off at 0, okay, and kind of make the angle get bigger and bigger and bigger until we get to 90. This is 0, 1, oops, other way around, 1, 0. And this is 0, 1. Okay? 43 degrees. 43 degrees is a little bit less than half. So if I come down here, let's look at that x-coordinate and look at that y-coordinate. Okay? That's a pretty big y-coordinate. Does it look like it's closer to 0 or closer to 1? Looks closer to 1 to me, doesn't it to you? Okay? So we'd expect something that's bigger than a half for that answer. The reason I tell you to think about that is if you have your calculator in the wrong mode or you plug something in wrong, it would be horrible if you think, oh great, I get a calculator problem. Plug it in, write down the answer, and then get it wrong. You should know roughly what you're expecting. If this is 43 degrees, we're looking for a y-coordinate that's positive. Is the answer positive? Yep. So if your calculator gave you something that's negative, you know you did something wrong. Okay, and we're looking for something that's fairly close to 1, a little more than half. Okay, so if I did something like this isn't on the paper, but listen. What if I said, what's the cosine of 84 degrees? Okay, it's going to be positive because 84 degrees would be about right here. It's going to be positive and it's going to be a pretty big number. It's going to be really close to 1. You with me? Okay, what if I said this? What if I said the cosine of 159 degrees? Cosine of 159. Oops. Cosine of 159. 159 would be about right here. Circle comes around like this. Cosine, which coordinate am I looking for? The x-coordinate. What's the first thing I notice about this x-coordinate? You're looking for a negative. So let's throw that in the calculator really quickly. And we're looking for a number that's pretty close to x-coordinate, -1. Okay, so if I did cosine 159, negative, that's pretty close to 1. Got it? Okay. What do you notice about this next problem right here? Cosine 1.9. Okay, it's not in degrees, it's in radians, so we'd have to change the mode of the calculator. This is 1.57, and this is 3.14. So, gosh, 1.9, about 2, maybe around there. So if we're looking for a cosine, are we looking for an answer that's positive or negative? We're looking for a negative, so let's have the calculator spit out the answer for us. So I'm going to go in here, I'm going to change the mode. I'm going to go with radians. You might have to hit the button that says mode on yours till it says RAD on the screen, depending on what type of calculator you have. And we're going to do cosine 1.9. Got a negative. 0.32. Okay, so there's the answer there. Okay, everybody watch, please. Okay, we'll tell you what, put your heads down for just a second. I'm going to do exactly the same problem again. I'm going to recall this. Okay, what did that just do? Can somebody tell me? Why did it give me a different answer? It thinks it's a degree. I put it in degree mode. So if you know what you're looking for, if you drew a picture of this and say, hey, I know I'm going to get a negative for an x value, for a cosine value, and it spits out a big positive number, you know you've got it in the wrong mode, or you know you typed something in wrong. Does that make sense? Okay. All right. And then this one right here, cotangent of 7 pi thirds. Let's take a good look at that. We ought to be able to figure this one out, but it's a little bit challenging. Cotangent of negative 7 pi thirds. So let's think about this for just a second. First of all, let's think of where we are. Negative, we're going to go around the circle this way. 7 pi thirds. Pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds. So where would I end up? I'd end up right here in quadrant 4. Does everybody see why? Okay, this is negative 7 pi thirds is negative 2 pi and then another pi thirds. Does that work? So it's all the way around in the clockwise direction and another pi thirds. So that puts us right here. What's this angle right here? Should be one that we know. All the ones that we're doing so far are ones that we know. 60 degrees. Okay, that means this is, help me out here, negative radical 3 over 2, and this one is 1/2. Cotangent of an angle. Cotangent of an angle, that's the reciprocal of tangent. So it wouldn't be opposite over adjacent, it would be adjacent over opposite. Or it would be the x over the y instead of the y over the x. Okay? Don't care how you do it. Either way, we're going to end up with this. We're going to take the adjacent, which is 1/2, and we're going to divide it by negative radical 3 over 2. So I'm going to flip that one over and multiply. So that's going to be a 2 on the top and a radical 3 on the bottom. Let's not forget the sign. Those cancel, so I end up with, let's see, this is negative 1 over radical 3. Do we like that? Not our favorite way to write it. There's nothing mathematically wrong with it, but if you had to use it again, you'd probably rationalize and write it as negative radical 3 over 3. Okay? Any questions? Okay. All right. Then let's finish up on this one. This is problem number 88, and then you're in great shape to do the assignment. This says the tangent of alpha is 1/70th, and alpha is in quadrant 1. Use this information to answer the following. So let's take a good look at this. Tangent of alpha is 1/70th, and it's in quadrant 1. So let's draw a picture of what this would have to look like. What two sides are involved in the tangent ratio? Okay, this is the opposite, and this is the adjacent. So let's draw what this triangle would have to look like. The opposite is 1, and the adjacent is 70. That's 1, that's 70. Okay? Could we figure out what the cotangent is? Yeah, how is the cotangent and the tangent? How are they related? They're reciprocals of each other. So this one's easy. Just flip that over. Could we figure out what the sine of that angle is? If alpha is right here, could we figure out the sine? Sure, but you've got to figure out the radius or the hypotenuse first. So this is going to be the square root of 70 squared plus 1 squared, right? Because if we say that's the hypotenuse squared would have to equal a squared plus b squared. 70 squared, 1 squared. Take the square root to get what h is. So this is going to be the opposite, which is 1 over the square root of 4901, I think is what it is. 70 squared is 4900. 1 squared is 1, so 4901. And then this one would be 70 over the square root of 4901. Because that would be the adjacent over the hypotenuse or the x-coordinate over the radius. Okay, are there any questions? Okay, listen carefully. Tomorrow, you are going to have some time in class to work because all we're going to do is we're going to take a quiz on 1.4 and the stuff that you've learned so far. So please make sure that you've memorized the stuff that I've asked you to have memorized. The quiz is probably going to take somewhere in the neighborhood of 20 minutes. So 1.3 is due tomorrow. We will correct that. The quiz will take about 20 minutes. So if you want to come here with some homework with 1.4, some questions to do, that's fine, but I wouldn't have more than 20 minutes worth of work to do in here. Your goal ought to be to leave here, class tomorrow, done with 1.4, everything up through 1.4, and all you need to do is make sure that you come back next week with everything memorized. Okay? No work to do, just some memorization to take care of. Any questions? Have a great day. Thank you for being here. I'll rarely keep you this long in office hours, okay? It's just this stuff is really important.